In today's video, I'm going to explain what Model Context Protocol, or MCP, is and why it's generating so much buzz in the AI world. If you've been following recent developments, you've probably heard the term. But what does it actually mean and why does it matter? Let's start with the problem. Imagine you have your own personal Einstein, an expert who can answer any question and solve any problem. This is essentially what today's AI is, your own personal Einstein, ready to help with virtually any task. But there's a catch. Einstein is locked in the basement. He can't access the internet, your files, databases, or any of your digital tools. All that intelligence is trapped simply because he's cut off from everything outside that basement. Now, there are already some ways to bridge this gap. For example, Retrieval Augmented Generation, or RAG, lets AI pull information from documents, and tools like Perplexity allow AI models to search the internet. But here's the issue. Every time you want to connect your AI to something new, whether it's a file system, a search engine, or a database, you have to build a custom integration. RAG needs vector databases, internet search requires special APIs, and every new source brings its own unique setup. Managing all these separate connections quickly becomes overwhelming, turning integration into a real headache. That's the problem MCP is designed to solve. Instead of building a new door or window every time Einstein needs to reach something outside the basement, MCP gives you a single standardized doorway, no matter what Einstein needs to connect to. Be it RAG, the internet, a database, or something else, he uses the same type of door every time. This makes it vastly simpler to link your AI to the world around it. So, what exactly is MCP? Model Context Protocol, or MCP, is an open standard and open source framework introduced by Anthropic in late 2024. Its main purpose is to provide a universal way for AI models to connect with external data sources, tools, and digital environments. Think of MCP as the USB-C of AI applications. Just as USB-C acts as a universal connector for all sorts of devices and accessories, MCP gives AI a standardized way to connect to different data sources and tools. Before USB-C, every device needed its own special cable. In the same way, before MCP, developers had to build custom integrations for every new system or tool they wanted their AI to access, a process that was complex and time-consuming. With MCP, developers can now use a single open protocol to securely and efficiently connect AI applications to whatever data or tools they need. Because MCP is fully open source, anyone can use it, contribute to it, and build new integrations, making it much easier to expand what AI applications can do from day one. To make this concrete, let's say you want to build an AI agent that helps your sales team prepare for client meetings by automatically gathering all the relevant information from your company's systems. Here's how MCP fits in. The MCP server is a small program that connects to your company's tools, like your CRM for client history, your email platform for recent conversations, and your calendar for upcoming meetings. Each tool would have its own MCP server, acting as a translator between that system and the AI. The MCP client is built into your AI assistant. When you ask the assistant to prepare a briefing for my next client meeting, the AI uses the MCP client to send requests to each MCP server. For example, get recent emails with this client, fetch open action items from the CRM, and look up the meeting agenda from the calendar. Each MCP server collects the requested data from its tool and sends it back through the MCP client to the AI assistant, which then summarizes everything for you. With this setup, you don't need to write custom code for every tool. As long as there's an MCP server for each system, your AI agent can pull together information from everywhere, all through a single standardized protocol. MCP isn't just theoretical, it's already being implemented in real business environments. While adoption is still growing, the protocol is enabling several key use cases. In enterprise settings, organizations are connecting AI agents to their internal business tools through MCP, automating repetitive workflows and allowing employees to focus on higher value strategic work. For example, an AI assistant can now pull data from multiple internal systems, generate reports, and even trigger actions across different platforms, all through standardized MCP connections. In the software development space, MCP is helping AI coding assistants become more powerful by giving them access to project codebases, documentation, and databases. This allows developers to ask questions about their specific code and receive contextually relevant suggestions rather than generic advice. Creative professionals are also benefiting from open-source MCP integrations for popular design and modeling tools. These connections allow AI to assist with tasks like 3D modeling, UI design, and digital art creation by understanding the context of the creative work and providing relevant suggestions or even executing commands directly in the software. As MCP adoption grows, we'll see AI assistants become more capable and useful in daily work. Instead of being limited to what they learned during training, they'll be able to tap into the vast ecosystem of digital tools and data we use every day. This opens up possibilities for AI to help with complex workflows that span multiple applications, access specialized tools, and work with personal or organizational data, all while maintaining appropriate privacy and security controls. And because MCP is an open standard, the community can continuously improve and expand its capabilities, creating a rich ecosystem of connectors that make AI more powerful and versatile. Thank you so much for watching, and I hope you'll join me soon in my next video.